For this video, I want you to pretend that my simulate signal here is the Dac Assistant that we will help you build in lab. So the Dac Assistant here is going to be gathering your information from your circuit. It's the white box with the green and red wires that are set up. What you're going to do is just click on Dac Assistant and then put it on the block diagram. So block diagram is the one with the white background. And you will go to acquire signals, analog input, voltage, and then here yours is set up for AI0 is what you should click on, and then click finish. Another box will come up that says would you like to add a while loop or something close to that, and I want you to say yes, and we'll set up most of it for you. The rest of it we'll go through as a class. Anyway, so pretend this right here is a Dac Assistant for this video. You're going to have some kind of signal being read, and we want to do a couple things with that signal. But first, I am going to create, right click and go to Signal Analysis, and I'm going to go to Tone Measurements. Okay. And then I'm going to click Amplitude and Frequency. Select both of those. Now, I want the signal that's coming out of my Dac Assistant, or my fake one here, and I'm going to click here and then into here. So when it's on the right side, the little arrow, that means this component can generate a signal, and it can output it to something that has a left arrow, or an arrow on the left side. So here I connected my signal from my fake Dac Assistant, or the simulate signal, to tone measurements. So now tone measurements, I'm going to right click on output amplitude, output frequency, and create, so right click and then down to create a numeric indicator. And then same thing for frequency, numeric indicator. Now I have this called as amplitude 2 and frequency 2 automatically because I'm already using amplitude and frequency for my fake function generator here. So akin to your function generator being turned, like the knobs, or you dialing it up, this is where I am turning my amplitude up and down, or my frequency. So then what I want to do is save these at some point, and we're going to do that by expanding this right click selection and go to programming, and then file, input, output here, and write measurement file. And I'm going to place that on there. Here I'm going to select text, LVM, no headers, empty time column, tabulated, and I'm going to append to file. So this is the two changes, I guess. Append to file and no headers. I'm also going to select a place that I want to save this, and I will save it just on my desktop, calling it lab5data. And I'll hit OK. So then I want my amplitude to be saved. I'll drag that into signals. And then I want my frequency to also be saved. So the way I can do this is just by combining these two signals like that. So I don't want to continually keep saving data to this file. I want to go to programming again, and then structures, and then case structure. So this is something similar to an if statement in C. Okay, so I put that around there. So this part here will only operate when something is true. Otherwise, when it's false, we won't do anything. What is that something? Well, we have to create some kind of indicator. We'll go ahead to text button. We'll just put this on here, and then save this up. And I want you to go right click on it, mechanical action, and then switch until released is what I want you to have selected. So then we find it right here. It's just that standard Boolean. Let's just call it saving. And we can connect this arrow into this little question mark right here. Okay. You can also control case structures with numeric values. So up here, instead of true and false, it would be, when the numeric value is, say, greater than 5, this would happen. So what is this going to do? It's going to allow us to run this program and then I can show you that there's no file here right now. But this whole thing is still working, and we can see our results here. If I turn up the amplitude, you can see the measured one is changing too. So I want to save some data. I'm going to go ahead and just hold on to this for a little bit, and let's save some data. Because when this is held down, this is true. So it's going to write to that file when this is held down. Otherwise, it'll keep doing this stuff, but it'll look more like this. So it won't save any data. So what you can do is turn up your amplitude, or I'm sorry, you won't be turning up your amplitude, but you'll be adjusting your frequency on the function generator. So I just hold on to some more data there. They turn it up more, save some more data, turn it up more, save some more data, and so on. So you can get an entire frequency response for your Bode plot. So let me just move this up here, and that's the those are the basic things that you need for this lab. However, I'm going to show you a couple more things that may be useful that you should look at as well. If we right click and go to Signal Analysis, I want you to go to Spectral Measurements and then place that on there as well, and then Linear for result, and do Power Spectrum for selected measurement, and keep handing window. I'm going to press OK, and then I can take this signal here, my sine wave, or for you it would be your Dac Assistant, and I'm going to place it inside the receiving signals here. So now I have spectral data, which you'll cover shortly in class, and my original data that's being read. So instead of just presenting it as numbers of frequency and amplitude, we also like to look at what it looks like when we plot multiple iterations of that, meaning a waveform. So if we go to Graph Indicator, by right-clicking that little triangle here, we're going to see something that looks like this pop up in our front panel. I forgot to mention, but the front panel is basically the user side of LabVIEW. So this would be like the background coding thing, and this would be like your GUI that the user can interact with and monitor things. So, you know, say when they want to save data, or when they can see this data. So we're also going to look at the graph here as well for the spectral data. And if I place this down here and just make it longer, I can just hit run, and we can see that this is saying my signal is somewhere between 400 and 600, which it is. I have it currently dialed up to 533. So if I change it to like 400, all of a sudden now this is going to 400 or 300. So it's showing me which frequencies are needed to combine to get this signal here. And we can see that it's some kind of function has a periodicity of 300, or a frequency of 300. So I think that's about it for this lab.